The automatic sprinkler system is the most cost-effective form of fire protection. Sprinklers are effective because they control and limit the spread of fire. That sounds simple enough, but how do sprinklers actually work? The sprinkler is designed to disperse water into evenly distributed droplets in an umbrella pattern over a predetermined area. This discharging water cools the fire area as well as pre-wetting surrounding combustibles. Thermoresponsive assemblies are designed to activate the head at a predetermined temperature to permit the flow of water, enabling the sprinklers to operate. The first and most common thermoresponsive assembly is the fusible link. It consists of 3 pieces of metal soldered together by a heat-sensitive metal alloy. When the heat reaches the head's operating temperature, the solder melts, the links separate, releasing lever arms and the cap, and the water begins to flow. Another thermoresponsive assembly is the glass bulb. When the head reaches its operating temperature, the chemical liquid expands and ruptures the glass bulb, and the sprinkler discharges water. Regardless of the thermoresponsive assembly used on a sprinkler head, they have one critical function: to actuate the head and the flow of water at the proper time. An essential factor in proper sprinkler operation is an adequate flow of water. At the same time, we do not want too many sprinklers to operate, as too much water discharging can overtax our supply or cause needless water damage. The sprinkler's density is described as the amount of water released over a specific floor area. It is usually expressed as gallons per minute per square foot. Density is a function of pressure and orifice size. Depending on the occupancy, more or less cooling water may be needed. In a furniture manufacturing plant, assembling of wood chairs is classified as an ordinary hazard because wood releases only 8,000 BTUs per pound per minute when it burns. A density of 0.2 of a gallon per minute per square foot provides adequate protection here. Polyurethane releases 13,000 BTUs per pound per minute when it burns. Because of the increased hazard of this material, we must increase the density to 0.3 of a gallon per minute per square foot. The first method we'll consider for increasing the density is to change the temperature rating using a higher rated temperature head. This allows more concentration of water on the immediate fire area. It has been proven that if the temperature rating of the sprinkler is too low, heads outside of the fire area will fuse in a high heat release fire. Using larger orifice sprinklers also increases the density. The orifice restricts the amount of water flowing from the sprinkler. When water flows between 2 points, friction loss occurs. How much pressure is lost depends on the diameter, the length, age, and interior condition of the pipe. Here we have 3 tubes. The one on your left is 1/2 inch in diameter. The middle one is 3/4 of an inch. And the one on your right is 1 inch in diameter. We'll open the valve and allow water to flow through the tubes into the containers. We can see that the 1 inch diameter tube permitted more water to flow, giving us higher density. We have just taken a basic look at sprinkler density and some ways to increase it. However, evaluating density requirements, calculating the system's ability to deliver the increased density, and determining the best method of achieving it is anything but simple.